Right, okay, so in this video we're going to have a look at frustums. Now it's a bit of an odd one, it's sort of like a cone with a little mini cone chopped off the top, and it's called a frustum, okay? So we're going to be having a look at working out the volume of these. We're going to build up to this type of question that I have on the screen. But before we do that, we're going to have a look at a cone and a slightly easier question and build it up to this type of question here. But I just wanted to see, obviously, which shape we're actually looking at here, because it's one of the more less seen shapes, okay, in mathematics, okay? But we're going to have a look at this sort of question. So grab a piece of paper, grab a pen, and we're going to get started. So when it comes to looking at frustums, we've obviously got to be pretty well versed in looking at the volume of a cone. Now the nice thing is we do get the volume of a cone given to us in the exams, okay, so we'll have this formula here, which I've got on the right over there. It's the volume of a cone is 1/3 pi r squared h, where r is the radius and h is the height. So in this type of question here, just making sure that we can actually put these bits and the bits we need into a calculator to make sure we can actually get the volume. So just a little quick practice question on this, just to make sure we're okay with that. So the height in this question is 8 and the radius is 5, okay, and you can always write that down to the side if you sort of want to, okay, so we can write h equals 8 and r equals 5, and from there all we really need to do is put them into our formula. So we've got 1/3 multiplied by pi multiplied by the radius squared, so 5 squared, you can always write 25 for that if you want, and then multiply that by 8. So just straight away putting that into the calculator there. Obviously if you have a Casio calculator, you can use your fraction button to get the third. If not, you'll have to use 1 divided by 3 and then start multiplying by the other pieces. But on my calculator I'm just going to do 1/3 multiplied by pi. You normally have to press shift to get your pi button, 5 squared, and then times 8. And pressing equals, making sure that you obviously get this number on your calculator before we go any further, so that you're happy about actually obviously using this formula. And I get the answer here of 209, and some more decimals here. We've got 439 5102. There we go, 5102. And there we go, that's the answer you should be getting on your calculator. Now just for the purpose of this question, we're going to be looking at rounding to 3 significant figures throughout this video. So we're going to round this to 3 significant figures, so 209, chop it after the third significant figure there, and that doesn't round up, so that would just stay as 209. And not forgetting units here, it's in centimetres and it's a volume, so it'll be centimetres cubed, okay? There we go, and there's our final answer for the volume of this cone. So all we're really going to be doing throughout this video is using this process. We're going to have a look at how we apply this onto frustums, and obviously just making sure that you're happy with obviously plugging all these numbers into your calculator and finding your pi button and putting that 1/3 into your calculator, which, as I've said, you can always put in brackets. You can, if you don't have a Casio calculator, you can always do in the bracket 1 divided by 3 and use that as your 1/3, okay? So just a little note there that obviously you can use that. And obviously if you don't have a pi button, you can always use the decimal 3.14, okay, throughout this video, just in case you don't have one of your calculators at home. Maybe you use a school calculator. If you've got something, you can always use these values as we go. It will make your answers slightly different to mine, but they will be good enough for you when you're practicing these, okay? So obviously if you don't have a Casio calculator, do your best to try and get hold of one, because they are absolutely fantastic. They are brilliant to use in the exam again. But here we go, let's have a look at our first question. Okay then, so looking at our first frustum, it says here a frustum is made by removing a small cone from a large cone as shown in the diagram. Work out the volume of the frustum and give your answer to 3 significant figures. So as you can see in the diagram here, we've got this little cone here that's been chopped off the top, okay, and that's what's created our frustum. Now when it comes to actually working this out, we're going to imagine to start with that it hadn't been chopped off, okay, so we're just going to imagine it's a big full cone there. And looking at that cone, okay, I'm going to label this the big cone. There we are, the big cone. We're going to work out the volume of that. Once we've got the volume of the big cone, we'll have a look at working out the volume of the cone that's been chopped off, and then we can just take them away from each other. Okay, we've just got to be careful though with that little cone, because obviously we've got all the values that we need for our big cone here, so we'll just have a look at that. So for the big cone, the radius down the bottom there, just be careful because that 30 in this particular one is all the way across, so the radius is obviously only halfway, and the radius of this one here is going to be 15. There we go, 15 centimetres. So the radius we're going to use is 15, and the height there of the big cone is 40 all the way at the top. So plugging all these values in, we get 1/3 times pi times the radius squared, which is 15, so 15 squared, and then multiplied by the height, which in this case is 40. There we go, and we type all that into the calculator. So 1/3 times pi, 15 squared, and then times 40. There we go, I'm putting all that in. It actually gives me the answer 3000 pi, although it does give me a load of decimals. Now it says in the question to give it to 3 significant figures. So if I'm going to write the decimal down, because not all calculators have the pi function there, if we write the decimal down, we just need to make sure that we write down at least 5 to 6 significant figures there. Ideally all of them, but definitely at least 5 to 6. So I get 9,424.777961. There we go, I'm just going to write it all down. So there we go, that is our volume of the big cone. Now moving on to the little one, we've got to do a little bit more maths behind this, because we've got to think about what the radius of that little cone is, and we can't see on the diagram exactly what that would be, and we're trying to find this little distance just here. There we go. And this is where we have to look at this in terms of a similar shape, in terms of a scale factor between the two. Now looking at the height of the little cone, which is given to us over here, the height of the little cone there is 20, and the height of the big cone was 40, so that's half the size. Okay, so to get from 20 to 40, we have to divide by 2, or you can look at it in terms of a scale factor. Okay, to get from 20 to 40, we would times by 2. Okay, or moving back the other way, we would divide by 2. And we're going to apply that same logic to our radius there. So to get from 15 up to our smaller radius, we need to divide that by 2. And that will give us a radius of 7.5. Okay, so looking at it in terms of a scale factor there, 1/2 of the size, so the radius up there is going to be 1/2 of the size as well. Okay, thinking about that in terms of similar shapes. So now we can go about working out the volume of the little cone. I'm just going to label that little cone. And there we go. I'm going to work out the volume of that as well. So working out the volume of the little cone, we've got 1/3 multiplied by pi, multiplied by the radius squared, which is 7.5. There we go, and then multiplied by the height, and the height of the little cone is 20. Right, there we go, so plugging that all into the calculator. So back into the calculator, I actually haven't deleted what I typed in before, so I'm just going to delete the 15, put the 7.5 in, and I'll delete the 20, and exchange that for 20, delete the 40 and exchange it for 20. There we go, and that gives us a volume. Again, mine's come out as an amount of pi, 375 pi. So I'll turn that into a decimal, and that gives me 1178.09 7245. There we go, and that's my volume of the little cone. Right, so we've got the two volumes now. Okay, I've got the little cone on top, I've got the full cone. I just need to take away that little cone from the overall big cone, and that will give me what's left over that's making up this frustum. So we just need to write down this calculation. We've got 9424.777. You know what? It's going to need a bit more space for that. Let's move that along. Right. 777961, and we are going to take away 1178.09 7245, and always make sure you show what you're working out here. And we're going to take that away. So what have we got? 9242. Just type that in the wrong way. 9424.777961. Take away that answer, and we get 8,246. Here we go. 8,246.6807. There you go, 16. And obviously, just referring back to the question, it does say give it to 3 significant figures. So we're going to chop that after the third, so 824, so after the 4 there. So that 6 after the line means it's going to round that up, so it's going to be 8250. There we go, and that is in centimetres again, so that'd be centimetres cubed. Right, there we go, and there's our final answer. Quite a lot of working out there, but there we go, we've got to our final one, 8250, 8,250 centimetres cubed. Again, the third significant figure there represents the tens value, that 4 does, so we're rounding that to the nearest 10 there with 3 significant figures in this particular example. But there we go, that's how you work out the volume of a frustum. All you do is you work out the volume of the big cone, work out the volume of the little cone, just being careful to obviously use the scale factor there to get the appropriate radius, and then just take them away from each other. And again, there we go, we get our overall volume of the frustum. Okay, now before we have a look at a slightly harder question, I've got one for you to have a go at, so here it is. Right, okay, so here's your question to have a go at, so pause the video there, have a go, and we'll go over the answers in a sec. Right, okay, so let's have a look. We have got a radius down the bottom of 5, okay, that's obviously a diameter of 10, so we need to split that in half. We've got a radius of 5. So for the big cone, Let's have a look. The working out we're going to do is 1/3 times pi times 5 squared times the height there, which is 14. There we go. And if we type all of that in, let's have a look. Try and do this as fast as I can. 1/3 times pi times 5 squared times 14. And that gives me the answer of 366.519. There's a few more decimals there, but I'm just going to leave it as 3 decimal places for the purpose of this. That's 6 significant figures there. On the next one, we've got the small one. So we need to find the radius of the small cone. Now, at the moment, and let's just highlight that, at the moment, the radius of the big cone is 5. It goes from 7 for the little cone to 14 for the big cone. There we go. So that is a scale factor of 2. So again, just like before, we are going to halve our radius there. There we go, to get the radius of the small cone up here, which will be 2.5. Okay, so putting all that into our formula, we've got 1/3 multiplied by pi multiplied by 2.5 squared, and then multiplied by the height of that cone, which is 7. So putting all of that in, and there we go, 2.5 squared multiplied by 7, and that gives me the answer 45.8148. So I'm just going to leave it to 3 decimal places, so 815, rounding that up, and that is the volume of my smaller cone. Okay, again to 3 decimal places there, which is 5 significant figures for that one, so a lot more accurate than we're needing for our final answer. Okay, so finishing that off then, we'll get the big volume, so 366.519 subtract 45.815. There we go, and let's type that in, 366.519 take away 45.815. And that gives us a final answer here of 320.704. There we go. And I want my final answer, not forgetting to 3 significant figures. So we'll chop that after the third, so 320, and that 7's going to round it up, so that is going to equal 321, check the units, centimetres cubed. Right, there we go, there's our final answer. Right there, so we're going to have a look at a different kind of frustum. Did show you one at the start, that's the one we're going to have a look at now, where potentially the scale factor is just a little bit different, but we'll have a look at how we'll approach that one as well, so here that is. Right, okay, so one of our harder type of frustums then. It says here a frustum is made by removing a small cone from a large cone as shown in the diagram. Work out the volume of the frustum and give your answer to 3 significant figures. So again, all the same language and just making sure we round it appropriately at the end as well. But we're going to have a look at this particular one and why it's maybe slightly different. Now, obviously the diagram's slightly different here. It's given me the height of the frustum and not the height of the little cone. But the overall height, look, is 15 centimetres and we've got 10 up to the top of the frustum. So the height of that cone there is going to be the extra 5 centimetres. So we'll write that in because we're going to need the height of that cone. There we are, it may or may not be given to you. This one it hasn't, so we'll just write it in, so 5 centimetres. Now having a look here, we've definitely got okay at getting the radius of the larger cone down the bottom. Look, half of the 12 is going to be 6. So we've got the radius there, but we need to figure out what the radius of the upper one is going to be. Now having a look, it goes from 5 down to 15, look. Okay, so that is being times by 3. So to get from this one this time, we're going to do the opposite of that. We're going to divide by 3, or essentially it's a third of the size. So to get from 6 up to the radius up here, we'll do the opposite. We'll divide by 3, and that's going to give us a radius here of 2 centimetres. Okay, so to be honest, the rest of the process is pretty much exactly the same. It's just that we had a slightly different scale factor there. The scale factor was 3 from the small to the big one, so we're going to divide by 3 going backwards to find that radius there. But the rest of the process is now exactly the same. So we're going to do the large cone, and again we're just going to do 1/3 times pi times 6 squared times 15. Again, you've just got to be careful, make sure that you don't use the diameter there. That's one of the biggest mistakes that you probably could make when you're just sort of trying to rush through this. Obviously, just make sure you always identify the radius. It's always a little bit of a hint just to write r equals down the bottom as well, and just obviously always identify the radius first. But plugging all those values in, let's see what we get. So 1 divided by 3, let's have a look, 1/3 times pi times 6 squared multiplied by 15, and that gives me 180 pi. And in fact, I might actually just do this one in terms of pi. Okay, so rather than writing down the decimal, I'm just going to leave it in terms of pi. So 180 pi, so that's what I'm going to use in my working out. It does actually come out as 565.4 0.487 if I round it to 3 decimal places, but you could just leave it in terms of 180 pi. Okay, it just makes it a bit easier to write it down on the screen as well. Now for the small one. There we go, and we've got 1/3 times pi times the radius, which is 2, which we identified, so 2 squared, and the height of that is 5, which we also identified. So again, let's just type all of that in. So 1/3 times pi times 2 squared, and at the end there times 5, and that comes out as 20/3 pi. Again, that's not very nice, sometimes they're not the nicest. 20/3 pi, which as a decimal is equal to 20.944 to 3 decimal places. 20.944. There we go. So there are our two volumes there. We've got the big cone and the small cone there. And again, we just need to take them away from each other. So to finish this off, look, we've got 565.487. There we go. And we're going to subtract 20.944. And let's see what we get. So 565.487, take away 20.944, and that equals 544.543. So 544.543. Okay, there we go. So obviously we need to round this to 3 significant figures. So we're going to round that off. So after the final 4 there, and that's a 5 afterwards. So that is going to go to 545 centimeters cubed. There we go, and there's our final answer. Right, okay, so very similar. Obviously, just watching out for the scale factor. So obviously that's how you're going to do some of these harder frustums, and here is one question for you to have a go at before we finish. Right, okay, so here's your last question. So pause the video there, have a go at this one, and we'll go over the answers in a sec. Okay, so for this one, obviously very similar to the last one, we've got a height here that's going to be missing from 8 up to 12. So from 8 to 12 is 4 centimetres, so the height of the little cone sitting on top that's been chopped off is 4 centimetres. Next thing, we can find the radius of both of them. So the radius of the big one down here is half of 18, so that's 9 centimetres. And then we just need to find the scale factor between the two. So from 4 to 12 as their heights, that is being multiplied by 3. So again, to get the radius here, we're going to divide by 3 to get up to our smaller one. Okay, so 9 divided by 3 gives us a radius of the small one here of 3 centimetres. Okay, there we go. So there's our two radiuses. I'd imagine if you managed to get the radius correct, you've probably got the rest of the process right, as the rest of it is very similar throughout the all the other questions that we've looked at. So again, we're going to get the small cone. So the small cone is 1/3 times pi times 3 squared. I've actually done it a bit different this time. On the other ones I found the large cone first, but there we go. And times 4 is the height. And for the large one, I'll write the working out down. There we go. For the large one, we get 1/3 times pi times 9 squared times the height of that, which is 12. There we go. And if we type these both in, we'll get the values for that. So let's have a look. 1/3 times pi, there we go, times 3 squared times 4. So that one there gives us a value. I could even do that in terms of pi. We'll see what the other one comes out as. We've got 12 pi. There we go, which as a decimal is 37.699 to 3 decimal places. And the other one, change that 3 for the 9 for the large cone. And we're going to times that by 12. There we go. And that comes out as 324 pi. There we go, which as a decimal is 1017.876. There we go. Right, so as we've got nice values of pi in this one, I'm going to just subtract the two values of pi on the calculator. Makes it nice and easy to write down. So we've got 324 pi, and we're going to take away 12 pi. There we go, and that leaves us with 312 pi. Obviously it wants the answer to 3 significant figures, so we do actually have to type that in and work it out, but there we go, we've got 312 pi, which comes out as 980.17. There we go, which is 980.17. It does go on for a little bit longer, but we only want 3 significant figures, so I'm just going to chop it after the third there, so 980, chop it after that, and we get 980, there we go, centimetres cubed. Right, there we go, and there's our final answer. Okay, there we go. So that is how you work out the volume of a frustum. Okay, it's something a little bit different in terms of the volume. It's not one of the shapes which is more commonly seen, but hopefully you can see obviously it is quite simple there. As long as you're able to put the numbers into the calculator and work out the volume of a cone, the rest of the process is quite simple. So hopefully you found that useful and helpful. If you did, please like, please comment, please subscribe, and I'll see you for the next one.